Key design issue of RISC architecture by Jagdish Sarode. So, what are the key design issue of RISC architecture? First is reduce instruction set. Second, optimize use of register, fix instruction size, and regularity among the operations. An important key issue of this RISC architecture is pipeline concept. We will see one by one in next slide. So first is reduce instruction set. Reduce instruction set is nothing but a reduced complexity of the instruction execution. It doesn't relate any reduced number of instruction in the instruction set of a processor, but it is a reduced complexity of the instruction execution. Instruction selection criteria for this reduced instruction set is only those instructions are included which fit into the pipeline structure. So the instruction which fits into the pipeline structure, those instructions are included in this reduced instruction set of the RISC processor. Then such derived pipeline which uses the reduced instructions must serve efficiently the three main class of instruction. So whatever the pipeline derived, it should support the three main class of instruction. First is access to cache or load store type of instruction. So pipelines must support load store type of the instruction. Then this pipeline must support arithmetic and logical operation of the instruction. And third, pipeline structure must support a branching instruction. So we choose those instructions which fits pipeline structure, and this main instruction for this pipeline structures are access to cache, arithmetic and logical operation, and branch instruction. And reduced instruction set of a RISC architecture comprises this load store type instruction, arithmetic logic instruction, and branch instruction. Next key point is optimize register use. So whatever the register used in the processor, we should optimally use that. And to optimally use the register, the access time of the register should be very small, and for smaller memory we achieve the faster work or faster access time, and hence to design a key design issue regarding this RISC architecture is short access time, and we achieve this short access time by using the internal cache memory, use of extensive use of internal cache memory. And this to use this internal cache memory we require frequent read and write operation, and hence this type of architecture which used for RISC architecture, it is a load store type of a architecture. Here load means to read from the memory and store means write a result to the memory. Then third important aspect or key points regarding optimized use of register is fixed size instruction. If our instruction size is fixed, we can optimally use the registers. Also we can schedule the instructions. Because our instruction is of fixed size, we can prepone that instruction, we can postpone that execution of the instruction, and instruction scheduling can be obtained by using this fixed size of instruction set, and we can increase the flexibility of the program execution. Again, instruction can get their data and write result from or to the registers. This is achieved because of this short access time. So every time instruction gets its data from the memory and writes its result to the memory registers. Then in optimized use of register, we use register numbers instead of its register name. So we can achieve the fast processing because we don't need to calculate the address of the register. We know the register number and we can directly go to that number, and no need of any calculation of the address of that register, and we can improve the performance of the RISC architecture. Third point is multiple access of the register. If multiple register can be accessed in parallel, we can read more register in less time, and hence we can improve the performance of the RISC architecture. So if we optimally use the registers in the processor, we can improve the performance of the RISC architecture, and hence optimized use of the registers is one of the key issue regarding the RISC architecture. Then fixed instruction size. Because of this fixed instruction size, as I told, simple alignment of pattern is required. Simple alignment of memory pattern required simple hardware design. We use internal memory for RISC architecture, and internal memory is simple alignment, having a simple alignment pattern, and to read and write such simple alignment of pattern we required a simple hardware, and hence we can use the fixed instruction size of the instruction. Then by using fixed instruction size we can achieve low addressing overhead. So there is no need of address calculation, and we can reduce the overhead of this address calculation by using this fixed instruction size. Then because of this fixed instruction, as I said, we can schedule the instruction execution, and by scheduling that instruction execution we can execute jump and branch instruction very fast, and we can achieve the fast performance by using this fixed instruction size by scheduling this jump and branch instruction. Generally, fixed instruction size of this RISC architecture is of 32-bit. Next concept is most important concept of RISC architecture is pipeline concept. Pipeline concept is nothing but a overlapping of execution of multiple instructions. So multiple instructions are overlapped in execution phase, and that type of execution is called as a pipeline architecture. Generally, pipeline architecture is of 5 stages: fetch, decode, execute, memory write, and result write. So here we can see that if first instruction is fetch, then it is in second stage it is get executed while second instruction is in the phase. Likewise, in third clock cycle, first instruction is executed, then second instruction is decoded, and third instruction is in the phase. So like if we go further, in fifth cycle we can achieve all 5 stages of the instruction, and we can say that one instruction is executed in one machine cycle. So when pipeline get filled, it execute one instruction per clock cycle. So assessment is, you have an assessment question: design 3-stage pipeline for RISC architecture. Thank you.